Welcome to EDU World Space.
In this problem, we're told that we have a spherical salad bowl, which I've drawn over here, and it's held about 16 centimeters in front of your nose, with the bottom of the bowl facing your nose. So here's the bottom of your bowl, and this green line represents your nose, and they're 60 centimeters apart. And then the bowl is basically acting like a mirror because the problem is saying it's covered in some silver, and it has a radius of curvature of 35 centimeters. So I put the absolute value since this is like a convex mirror, so the radius will be negative. And we're asked to find where is the image of your 5 centimeter tall nose. So we're given that the height of your nose is 5 centimeters. Where is the image of your nose located? So it's kind of easy to see visually if you drew some of the principal rays. So let's take one that goes through the center. So it goes through the center. That's supposed to be a straight line, but kind of did a horrible job. And so it'll go here and it'll bounce right back because it's going through the radius. And so then we take one that's symmetric about the optic axis, so it will reflect in a symmetric way here. And then we extend that reflected line. So we have the image then is somewhere over here. Okay, so that kind of helps us orient ourselves. And now we'll do the actual computation. So let's get to the next page. We'll use equation 34.6, which tells us that 1 over s, where s is the distance of your nose to the bottom of the bowl, plus 1 over s prime, and s prime is the distance from the bottom of the bowl to the image of your nose that's formed in the reflective surface of the bowl. And that is equal to 1 over the focal length. Now again, the focal length, let me write the absolute values for now, is the radius of curvature over 2. So that's just the magnitude of the focal length, but we know that r is less than 0 for convex mirrors. So the focal length then will be minus 35 centimeters, because that's what we're given. We're radius of curvature divided by 2, and that is minus 17.5 centimeters. And again, we would like to find where the image of your nose is located, so we can isolate this equation and basically solve for s prime. So we have s prime is equal to fs over s minus f. And we have we were given the numbers for all these things. We just actually computed f here, so that is minus 17.5 centimeters, and s we were given is 60 centimeters, and then we have 60 centimeters minus 17.5 centimeters, and this results in minus 13.55 centimeters. So that is where the image is formed. And then in part B, we're asked what are the images, size, orientation, and nature. So nature refers to whether it's real or virtual. So this is part A. And part B now. Let's tackle the size of the image. So we'll use equation 34.7, which tells us that the magnification is equal to minus s prime over s, which is also equal to y prime over y. And y prime is the height of the image, and y is the height of the object. So in this case, the height of your nose, and y prime will be the image form of your nose in this convex mirror. So from here, let's first determine m using this part of the equation. Or rather, let's combine the two already and just get it over with and solve for y. So we have minus s prime over s is equal to y prime over y, which tells us that y prime is equal to minus s prime over s times y. And we have that y prime then is equal to minus s we just found up here in part A, minus 13.55 centimeters. And s we know is 60 centimeters. And y we're given is 5 centimeters. And that gives us 1.15 centimeters. And this here is actually the magnification. As for the orientation, we have the magnification is given by minus s prime over s, which is minus 13.55 divided centimeters divided by 60 centimeters, and that is 0.23. So that is not negative, so it's greater than 0. So if it's greater than 0, that means that m greater than 0 means that the image is erect. And the nature, well, that is determined by whether s prime is greater than 0 or s prime is less than 0. But we found that s prime is less than 0. So this means that it's real, and this means that it's virtual. And this is the case that we actually found. This is s prime here.